Hello friends, I hope you all are fine. Today I am going to solve 25 problems of trigonometry of high school level or class 10th level. I am assuming that you will be also solving along. So I request you to pause whenever you see a new question and first try and solve it yourself. Okay? Now these questions, students usually find them difficult in class 10th. So just to practice, I am making this video. So I hope you will practice along. As you can see, in the first question, it is saying 1 plus cot square A upon 1 plus cosec A is equal to cosec A. So we'll start with the left hand side. On the left hand side, we will start with 1 plus, instead of cot square A, we can write like this. We know cosec square A is equal to 1 plus cot square A. So from that we can write cot square A is equal to cosec square A minus 1. So in place of this cot square A, it is, let me write this down first, plus 1 upon cosec A. So what we will do? We will do 1 plus cosec square A minus 1 upon 1 plus cosec A. Now here what we will do? We can see it is cosec square A minus 1. That is A square minus B square. So we will do using A square minus B square is equal to A plus B, A minus B. So what will it come? It will come to be cosec A minus 1 cosec A plus 1 upon 1 plus cosec A. This will cancel out. It will become 1 plus cosec A minus 1, and then 1 and 1 will cancel out, 1 and minus 1 will cancel out. So we will be left with cosec A. Now this is the right hand side. We had to prove this. Okay, so we are done with the first question. Now we move to the next question. So I request you to pause the video over here and try and solve it by yourself. I hope you all must have tried. I will not give the instructions again and again. It is understood from the next question onwards. So we'll again start with the left hand side. In the left hand side, it is cos square theta upon 1 minus tan theta plus sec cube theta upon sin theta minus cos theta. This is the left hand side. Now we can write down using, we are using tan theta is equal to sin theta upon cos theta. So what we will do? We will do cos square theta upon 1 minus sin theta upon cos theta plus sin cube theta upon sin theta minus cos theta. So this will become cos cube theta upon cos theta minus sin theta. We'll change the sign over here and we'll make it same, the denominator will make it same, cos theta minus sin theta. So this will become something like this: cos cube theta minus sin cube theta upon cos theta minus sin theta. Now I am going to use a cube minus b cube is equal to a minus b, a square plus ab plus b square. Okay, so we will use cos theta minus sin theta, cos square theta plus sine square theta plus cos theta sin theta. In denominator we have already cos theta minus sin theta, so this will cancel out. We are left with cos square theta plus sin square theta plus sin theta cos theta. Now since we know, since sin square theta plus cos square theta is equal to 1, therefore it turns out to be 1 plus sin theta into cos theta. Now this is the right hand side, we have to prove this, and this is proved. We have used the tan value of tan over here, sin theta upon cos theta, and then we use the formula a cube minus b cube, and then we use the identity sin square theta plus cos square theta over here. Okay, now moving on to the next one. In this one, what are we left with? In this one we are having sin theta 1 plus tan theta cos theta 1 plus cot theta is equal to sec theta plus cosec theta. Okay, so what we will do, we will simply, we'll start with the left hand side again, and we'll write sin A 1 plus tan A plus cos A 1 plus cot A. See, the easiest thing to do is convert everything into sin and cos. So tan I can write, tan theta I can write sin theta upon cos theta, and cot theta I can write cos theta upon sin theta. So if I substitute these values, what will I get? I will get sin A 1 plus sin A upon cos A, and cos A 1 plus cos A upon sin A. Okay, now what will happen is, we will add this sin theta, and then what will happen over here is cos theta plus sin theta plus denominator will come down cos theta. Here it will happen cos A. I have written everywhere theta. Let me remove this. Sin A cos A, sin A cos A, sin A plus cos A, and this will be sin A. Now I will take sin A plus cos A common. So what will happen is, it will become sin A upon cos A plus cos A upon sin A. Okay, so next what we will do, we will do sin A plus cos A sin square A plus cos square A upon sin A cos A. Now again using sin square A plus cos square A, using sin square A plus cos square A is equal to 1. The whole thing will become 1, and we will get over here sin A plus cos A upon sin A into cos A. So what will this become? This will become sin A upon sin A cos A plus cos A upon sin A cos A. sin A will get cancelled out, cos A will cancel out. This will become, now 1 upon cos is sec A and 1 upon sin A is cosec A. So it will become sin A sec A plus cosec A. Okay, that was the right hand side over here. That was what we wanted. So sin A, it will become sec A plus cosec A is equal to right hand side. Okay. Now moving on to the next question. In this question you can see we have to do sec square minus sin square A minus 2 sin square A upon 2 cos 4A minus cos square A. So how will we start? We will simply do with the left hand side will start and it will become sec square theta minus sin square theta minus 2 sin 4 theta upon 2 cos 4 theta minus cos square theta. Now what will I do? Sec square theta, I will take sin square theta common from above. Sin square theta, it will become 1 minus 2 sin square theta, and from denominator I will take cos square theta, it will become 2 cos square theta minus 1. Okay, then I will do sec square theta minus sin square theta in numerator. Instead of, you will again using sin square theta plus cos square theta is equal to 1. Instead of sin square theta we will write 1 minus cos square theta upon cos square theta 2 cos square theta minus 1. Let's see how this works out. Sec square theta minus tan square theta, sin square theta upon cos square theta is tan square theta, and it will become 1 minus 2 plus 2 cos square theta. In the denominator it will be 2 cos square theta minus 1. I can write down sec square theta minus tan square theta 2 cos square theta minus 1 upon 2 cos square theta minus 1. Now this will cancel out and I will get sec square theta minus tan square theta. This is equal to 1. This is equal to 1. That is the right hand side. We had to prove this only. We had to prove that this was equal to 1. In the end, we will be using the identity 1 plus tan square theta is equal to sec square theta, you can say, or sec square theta is equal to 1 plus tan square theta. Moving on to the next question. Here you can see we have been given two identities. We have been given two square roots. Under root sec A minus tan A upon sec A plus tan A multiplied by cosec A minus cot A upon cosec A plus cot A. So what the first thing we will do is we will write it down in sin theta upon cos theta. We will try and convert everything in the left hand side to sin theta upon cos theta. Now see, we can write sec theta as 1 upon cos, it's A, cos A. Tan I can write as sin A upon cos A. Sec I can again write as 1 upon cos A. Tan I can write as sin A upon cos A. If I multiply it, cosec I can write 1 upon sin A. Cot I can write as cos A upon sin A. Cosec I can write 1 upon sin A, cot I can write cos A upon sin A. So what will this become? This will become under root 1 minus sin A upon cos A upon 1 plus sin A upon cos A multiplied by under root 1 minus cos A upon sin A under root 1 plus cos A upon sin A. Cos and cos will cancel out, sin and sin will cancel out. Okay. Now what will happen? It will become something like this: 1 minus sin A upon 1 plus cos A multiplied by 1 minus cos A 1 plus cos A. Just a minute. This is sin A. Now what we will do? We will multiply the left side by 1 minus sin A and the right side by 1 minus cos A. We will do it like this. We will multiply the left hand side, both the numerator and the denominator, by under root 1 minus sin A. This will become 1 minus sin A upon 1 plus sin A 1 minus sin A. See, when we will do this, the numerator will become square and it will come out of the under root, and the denominator we can use the identity, the algebraic identity A plus B, A minus B, that will become A square minus B square, and that will become 1 minus sin square, and 1 minus sin square is cos square. We will do similar kind of thing over here. We will multiply it by 1 minus cos A and we will write 1 plus cos A multiplied by 1 minus cos A. Okay, so this will become, it will become something like this: 1 minus sin A whole square upon 1 minus sin square A multiplied by 1 minus cos A whole square upon 1 minus cos square A. Now we will be using sin square A plus cos square A is equal to 1. So 1 minus, if this goes over here, 1 minus sin square, it will become cos square A. So what can I write? I can write 1 minus sin A whole square upon cos square A. Similarly, if I take this over this side, 1 minus cos square A, it will become sin square A. So it will become 1 minus cos A whole square upon sin square A. So what will happen to the under root? It will become 1 minus sin A upon cos A into 1 minus cos A upon sin A. Okay, let us take a look at what did we have to prove. We had to prove cosecA minus 1 upon sec A minus 1. CosecA minus 1 upon sec A minus 1. Now what we will do over here is, we will interchange the denominators. We can do that. Since they are multiplying, we can write 1 upon sin A upon sin A. We will bring this one over here and this one over here, multiplied by 1 minus cos A upon cos A. So this will become 1 minus, this will become 1 upon sin A minus sin A upon sin A multiplied by 1 upon cos A minus cos A upon cos A. So this will become cosecA minus 1 and sec A minus 1. We have to prove it. CosecA minus 1 and sec A minus 1. You can see over here, we have to prove cosecA minus 1, sec A minus 1. The trick over here is that the only part where I think you will get stuck is that you have to change the denominators over here in this step. You have to change these denominators over here. So that is the part I think where students will mostly get stuck, but other than that, this is a pretty simple question. Okay, now let's move on to the next question. I hope you all are pausing the videos and trying to solve it by yourselves. Okay. It is the sixth part. 1 minus cot A minus cosec A, 1 plus tan A plus sec A is equal to 2. So in this question also, we will first convert everything into sine and cos. We'll start with the left hand side. Left hand side is 1 plus cot A minus cosec A, 1 plus tan A plus sec A. So it will be 1 plus cos A upon sine A. Cot we can write cos upon sine. Cosec we can write 1 upon sine. If you want to know all the trigonometric formulas, I will give a link in the description. From there you can see all the trigonometric formulas that are being used in this video. I will also give you a link for the algebraic descriptions, for the algebraic identities as well as trigonometric identities in the description. Tan theta you can see sine A upon cos A. You should know them by heart if you want to solve such questions. 1 upon cos A. Okay, now we'll take the LCM. We'll take the denominator common. The LCM is sine A. So this will become sine A. This will become sine A plus cos A minus 1 cos A plus sine A plus 1 upon cos A. This will become A minus B, A minus B, A plus B. So it will become you will be using A plus B, A minus B, that is A square minus B square. Sine A plus cos A whole square minus 1 upon sine A cos A. Okay. Next step what we will do, we will open this using A plus B whole square, using A plus B whole square. I hope everybody knows it is A square plus B square plus 2AB. So when I open it, it will become sine square A plus cos square A plus 2 sine A cos A minus 1, and this will become sine A cos A. It is already sine A cos A. Then we will be using sine square A plus cos square A over here. What is the identity? Identity is using sine square A plus cos square A is equal to 1. So this will become 1 plus 2 sine A cos A minus 1 upon sine A cos A. These both will cancel out. This will become 2 sine A cos A, and in the denominator we have sine A cos A. This will also cancel out, and this will become 2. That is the right hand side. This will become 2. That is the right hand side. I hope you are able to solve it by yourself. Now let's move on to the next question. Okay. Now in this question, we can see they have different denominators, and the question is already in sine and cos. The question is already in sine and cos. So we'll simply take the LCM of the denominators for the left hand side and then see what happens. We will make the denominator same. So it is sin theta upon 1 plus cos theta plus 1 plus cos theta upon sin theta. So when I take the LCM will be sin theta 1 plus cos theta for denominators, and the numerator here will be multiplied by sin square theta, and here it will be multiplied by 1 by 1 plus cos theta whole square. Now I'll again use the algebraic identity a plus b whole square. So sin square theta will become 1 plus cos square theta plus 2 cos theta upon sin theta 1 plus cos theta. Now if used for these two, what I will do, I will use the identity using sin square theta plus cos square theta is equal to 1. So this will become 1 plus 1 plus 2 cos theta upon sin theta 1 plus cos theta. It will become 2 plus 2 cos theta upon sin theta 1 plus cos theta. So what will happen is 2 1 plus cos theta upon sin theta 1 plus cos theta. So this will cancel out, and we can write 2 upon sin theta, or we can write 2 into 1 upon sin theta. What is 1 upon sin theta? It is 2 cosec theta, and this is the required right hand side. This is the required right hand side. Student, I hope you are getting everything. We have only used here we have used a plus b whole square is equal to a square plus b square plus 2ab, and then we used sin square theta plus cos square theta is equal to 1, and then what we used? We used 1 upon sin theta is equal to cosec theta. Okay. Now in the next one, it is shown that sec 4 theta is equal to tan square theta plus tan 4 theta. So in this one, what can we see? In this one, we start with the left hand side. We already know that there is a relation between sec square theta and tan square theta. The relation goes at sec square theta is equal to 1 plus tan square theta. So we'll try and do something over here. We won't convert it into sine and cos. So left hand side is sec 4 theta minus sec square theta. What we will do, we'll take sec square theta common. So what will happen? Sec square theta minus 1. So what can we see? We can see that instead of this sec square theta, I can write down 1 plus tan square theta. And instead of this sec square theta minus 1, if I bring 1 over here, I will have to write down tan square theta. Now I will multiply it over here. It will become tan square theta plus tan 4 theta. This will become the right hand side. Hence proved. This was a pretty simple one. Now let's move on to the next one. In the next one, what they have done is this. It is in sin A 1 plus tan A plus cos A 1 plus cot A is equal to sec A plus cosec A. Again, we'll convert everything into sine and cos, because already two of them are in sine. One is in sine A, one is in cos A. So we will convert everything into sine and cos. Let's start. Left hand side, sin A 1 plus tan A plus cos A 1 plus cot A. If I convert it into sine and cos, sin A, I hope by now you know that tan A is sin A upon cos A, and cos A, what is cot A? 1 plus cos A upon sin A. Okay, so what can I do? I can do something like this. Sin A, it will become cos A plus sin A upon cos A plus cos A sin A plus cos A upon sin A. Now what we'll do, we'll take sin A plus cos A as common. We'll take sin A plus cos A as common. Sin A plus cos A will take common. We will be left with sin A upon cos A plus cos A upon sin A. Now we'll do it like this. Sin A plus cos A we have. It will become sin square A plus cos square A upon sin A plus, sin A cos A. We have taken the LCM of the denominator and multiplied them. So it will become, again we will be using sin square A plus cos square A is equal to 1. So sin A plus cos A 1 upon sin A cos A. And then what we will do? We will multiply it. Sin A upon sin A cos A plus cos A upon sin A cos A. Sin and sin will cancel, cos and cos will cancel over here. It will become 1 upon cos A plus 1 upon sin A. So we will be left with sec A plus cosec A. That is the required right hand side, sec A plus cosec A. Okay, students. So we'll move on to the next question. In this question, he has given us 1 upon 1 plus tan square A plus 1 upon 1 plus cot square A, and then we have to prove it 1 is equal 1 upon cos square A minus cos to power 4A. So what will we do? We will simply convert everything into tan. See, where we will try, we know that sec A can be written as cosec A. Sec A can be written as something like cosec A. And tan A, cot A. So we will try and use identities. 1 plus cot square A is equal to cosec square A, and 1 plus tan square A is equal to sec square A. We also know 1 upon tan A is equal to cot A. Similarly, 1 upon cot A is equal to tan A. So what can I write? I can write it 1 plus cot square A, 1 plus tan square A. This is my left hand side. Instead of 1 plus tan square, I have written cot square A, 1 plus cot square, I have written tan square A. And then what I can do? Instead of cot square A, I can write down cosec square A, 1 plus tan square, I can write down sec square A. Sec square A. Cosec square A, I can write down 1 upon sin square A. Cos square, sec square, I can write down 1 upon cos square A. Sin square A I can write as 1 upon 1 minus cos square A. Why? Because sin square A plus cos square A is equal to 1. So I can write it instead of sin square A 1 minus cos square A. And then what I will do, I will 1 upon cos square A, I will multiply them. So I will get 1 upon cos square A minus cos 4A. This is the right hand side. Hence proved. Okay. Now we will move on to the next question. In the next question you can see they have given, again you can see they have given 2 upon cos square theta minus 1 upon cos 4 theta minus 2 upon sin square theta plus 1 upon sin 4 theta. We have to prove is equal to cot 4 theta minus tan 4 theta. Tan cot power 4 theta minus tan power 4 theta. So we will be again using the same identities that we used in the last question. I can write the left hand side is 2 upon cos square theta minus 1 upon cos 4 theta minus 2 upon sin square theta plus 1 upon sin 4 theta. Now what I can do is, I know 1 upon cos is sec and 1 upon sin is cosec. Cosec theta, cosec theta. So I can write 2 sec square theta minus sec 4 theta. Okay, minus 2 cosec square theta plus cosec 4 theta. This is sine, so I will convert into cosec, and this is 1 upon cos, it will convert into sine. Now instead of sine theta, sec square theta, I will write in sec square theta is 1 plus tan square theta. I have already told you many times. And this I will write as 1 plus tan square theta is sec square theta, but this is 4. So I will do multiplied by 2. Same thing I will do, cosec square theta is 1 plus cot square theta, and this one I will write plus 1 plus cot square theta whole square. So this will become 2 plus 2 tan square theta minus, this will become 1 plus tan 4 theta plus 2 tan square theta. This will become plus 1 plus cot square theta. Sorry, this is not plus, this is minus. This is minus over here. Plus 1 plus cot 4 theta plus 2 cot square theta. Okay. So what can we see? This is plus, this is minus. Here is a minus sign over here. So, and this is minus. Here also there is 2. It will become 2 cosec square theta and 2 cot square theta. This will also cancel out by this. This will become 2 minus 1 will become 1 plus tan 4 theta. And here it is minus 2 plus 1. It will become minus 1 plus cot 4 theta. Okay. Here you can see it will come about to be minus, because there is a minus sign over here. So this should come out to be minus. So my 1 plus 1 minus 1 will cancel out. It will become cot 4 theta minus tan 4 theta. This is the right hand side. Okay. Now let's move on to the next question. I hope you are understanding, and better than that, you are solving it by yourself. Okay. In the next question, it is question number 12. In question number 12, it is under root sec theta minus 1 upon sec theta plus 1 plus under root sec theta plus 1 upon under sec theta minus 1 is equal to 2 cosec theta. We have to prove that it is 2 cosec theta. So how will we start? We will start by taking the LCM. We will start by taking the LCM, and what will happen is we will start with the left hand side, under root sec theta minus 1 sec theta plus 1 plus under root sec theta plus 1 sec theta minus 1. We will take the LCM. LCM is under root If we take the LCM, it will be under root sec theta plus 1 and sec theta minus 1. Now we will have to multiply the numerator here by sec theta minus 1. So it will become sec theta minus 1 whole square plus under root sec theta plus 1 whole square. So this will become what? This whole square and under root will cancel out. It will become sec theta minus 1 and this one will become plus sec theta plus 1 and this will become under root sec square theta minus 1. Now sec square theta minus 1 is tan square theta. Sec square theta minus 1 is tan square theta. And what will happen over here is minus 1 plus 1 will cancel out. So it will become 2 sec theta. Sec square theta minus 1 is under root tan square theta. It will become 2 sec theta upon tan theta. 2 upon 1 upon cos theta is sec theta and tan theta is sin theta upon cos theta. So it will cancel out 2 2 and we will get 1 upon sin theta. This is 2 upon 2 cosec theta. This is the right hand side that we had to prove. We had to prove that this was 2 cosec theta. Okay. Now let's move on to the next question. In the next question, student, I will give you a reminder again that I hope you all are pausing the videos whenever a new question comes and trying to solve it by yourself. If you just keep on looking, you won't learn anything. The whole idea is that you look at it and you learn something. Okay, that you learn something out of it. Okay, so let's start over here. In this also there is left hand side is sin theta 1 plus tan theta plus cos theta 1 plus cot theta is equal to cosec theta plus sec theta. So now what we will do is we already there one term has sine and the other term has cos, so we'll convert everything into sine and cos. We'll convert everything into sine and cos. We start with the left hand side. Left hand side will become sin theta 1 plus sin theta upon cos theta plus cos theta 1 plus cos theta upon sin theta. Cot theta is cos theta upon sin theta. So it will become sin theta plus sin square theta upon cos theta plus cos theta plus cos square theta upon sin theta. Sin theta plus cos theta plus sin square theta upon cos theta plus cos square theta upon sin theta. Now we will, for these two terms, we will take the LCM of the denominators and multiply them, and then we will try and simplify these two terms first. We will get, when we take the LCM, we will get sin theta into cos theta, and the numerator over here we will have to multiply by sin theta. So it will become sin cube theta. This one will become cos cube theta. We will be using here identity a cube plus b cube over here is equal to a plus b a square minus ab plus b square. I will give a link in the description for all the identities, both trigonometric and algebraic. So sin theta plus cos theta, it will become, we can write this one in bracket also, sin theta plus cos theta sin square theta minus sin theta cos theta plus cos square theta upon sin theta cos theta. We will take sin theta plus cos theta as common. Okay, and we will be left with 1 plus, here sine square theta plus cos square theta will become 1. 1 minus sine theta cos theta upon sine square theta upon sine theta cos theta. Now what we will do over here is we will separate them. Sine theta plus cos theta, 1 plus 1 upon sine theta cos theta minus sine theta cos theta upon sine theta cos theta. This will cancel out and become 1, and this will become sine theta plus cos theta, 1 plus sine theta cos theta minus 1, plus 1 and minus 1 will cancel out, and then this will become sine theta plus cos theta, 1 upon sine theta cos theta, sine theta upon sine theta cos theta plus cos theta upon sine theta cos theta. Sine theta and sine theta will cancel out, cos theta and cos theta will cancel out. 1 upon cos theta will become sec theta, 1 upon sine theta will become cosec theta. I think this was the left hand side, right hand side, cosec theta plus sec theta. This one was a little lengthier, but I hope you must have understood it. We have to use this identity a cube plus b cube over here, okay? And then over here we have to use sine square theta plus cos square theta is equal to 1. Okay? Now we will move to the next part. Next part is the 14th part. The 14th part is, you can see in this, the right hand side is 1 upon sine square theta minus cos square theta. So we'll again convert the left hand side into sine square, sine in terms of sine and cos. There is tan. Now tan is equal to, I will write over here, tan theta is sine theta upon cos theta. Then we have sec theta. Sec theta is 1 upon cos theta. And then we have cosec theta. Cosec theta is 1 upon sine theta. So we'll convert it like this. So tan theta will become, left hand side will start tan square theta upon tan square theta minus 1 plus cosec square theta upon sec square theta minus cosec square theta. Tan theta will become sine square theta upon cos square theta, and then tan square theta will become again sine square theta upon cos square theta minus 1. Cosec square theta will become 1 upon sine square theta, and sec square theta will become 1 upon cos square theta minus 1 upon sine square theta. Okay, so what will we do over here? We will get sine square theta upon cos square theta, and denominator we will take the LCM, sine square theta minus cos square theta whole divided by cos square theta plus 1 upon sine square theta. Here it will become sine square theta minus cos square theta whole divided by sine square theta cos square theta. So from what can we see? We can see that this cos square theta and this cos square theta will cancel out. This sine square theta and this sine square theta will cancel out. And then it will become sine square theta upon sine square theta minus cos square theta plus cos square theta upon sine square theta minus cos square theta. Okay, so now what we will do, now the denominators are same, so I can write sine square theta plus cos square theta upon sine square theta minus cos square theta. Or the numerator will become 1 upon sine square theta minus cos square theta. I think we have to prove this only, 1 upon sine square theta minus cos square theta, and we have proved this. Students, if you are having any doubts, please ask in the comment section. I will definitely reply to them. Now the next question is, here what are we going to use? Here we are going to use a cube plus b cube and a cube minus b cube. We are saying it is cot cube plus sine cube theta. Let me check. I think this I have copied this down. Copied this wrong. This is not cot cube theta. This is cos cube theta. So there is a correction over here. It is cos cube theta plus sine cube theta upon cos theta plus sine theta plus cos cube theta minus sine cube theta upon cos theta minus sine theta. It is not cot, it is cos. There is a correction over here. So what can we say? We start with a cube plus b cube is equal to a plus b, a square minus ab plus b square. A cube minus b cube, a minus b, a square plus ab plus b square. So what can we write down over here? We can write down cos theta plus sine theta cos square theta minus cos theta sine theta plus sine square theta whole upon cos theta plus sine theta plus cos theta minus sine theta cos square theta plus sine square theta plus cos theta sine theta upon cos theta minus sine theta. This and this will cancel out, this and this will cancel out. Cos square theta plus sine square theta is 1. Cos square theta plus sine square theta is 1. So what can I say? 1 minus cos theta sine theta, and this will become plus 1 plus cos theta sine theta. These both will also cancel out. This is minus, this is plus. This will become 1 plus 1. That is 2 is equal to right hand side. Okay, students. Next, now let's move on to the next question. The next question is, in the next question it is 2 sine power 6 phi plus cos power 6 phi is minus 3 sine power 4 pi plus cos power 4 pi is equal to plus 1. Okay, so what will we do? In this question we will try and solve it using a cube plus b cube. I think we should apply a cube plus b cube only. We will apply a cube plus b cube. Okay, and then we will see what can we do regarding remaining. First, let's apply a cube plus b cube over here. A cube plus b cube. We have applied in last question also. We know a cube plus b cube is equal to a plus b, a square minus ab plus b square. This is 2 sine square phi whole cube plus cos square phi whole cube. We can write it like this, the left hand side, and then we write 3 sine 4 phi plus cos 4 phi plus 1 is equal to 0. Okay, so what can we write? We can write a cube plus b cube. We can write 2 sine square phi plus cos square phi. This is the a plus b, and then we will write sine 4 phi, this is a square, minus sine square phi cos sine square phi cos square phi, this is minus ab, plus cos 4 phi. Okay, and the remaining part will come as the same. It is, we'll see what we'll have to change. It is sine 4 phi plus cos 4 phi plus 1. Okay, from here I should remove, since this is only the left hand side. Okay, now what will happen is sine square theta and cos square theta will become 1. This will become 1. So it will become 1. Sorry, we have 2 outside. This will become 1. So it will become sine 4 phi minus sine square phi cos square phi plus cos 4 phi minus 3 sine 4 phi plus cos 4 phi plus 1. Now what can we say? We can see that we have 2, let's multiply it, 2 sine 4 phi minus 2 sine square phi cos square phi plus 2 cos 4 phi minus 3 sine 4 phi minus 3 cos 4 phi plus 1. Now what will I get? Here I will get 2 cos 4 phi or minus 3 cos 4 phi. It will become minus sine 4 phi. Similarly, 2 cos 4 phi minus 3 cos 4 will become minus cos 4 phi minus 2 sine square phi cos square phi plus 1. So here I can use, I can take minus common. It will become sine 4 phi plus cos 4 phi plus 2 sine square phi cos square phi plus 1. It will become minus sine, here we are using a square plus b square plus 2ab is equal to a plus b whole square. So it will become sine square phi plus cos square phi, this is a plus b whole square plus 1. Now sine square theta plus cos square theta is, sine square phi plus cos square phi is 1 square plus 1. So minus 1 plus 1, this will turn out to be 0. That is the right hand side. I think this is a little tricky one, but you can do it. So you should do it. Since you can do it, you should do it. If you want, you can look at it again. Okay. Here we are using, first we are using a cube plus b cube over here to open this one. And once we have opened this, then we are applying sine square theta plus cos square theta over here. Then we are simplifying it with the remaining terms, and then we are using a square plus b square plus 2ab is equal to a plus b whole square. And then we are using sine square theta plus cos square theta is equal to 1. And then we are getting this. Okay. Now let's start with the next question. Next question is question number 17. Question number 17. Now in question number 17 it is saying 3 sin theta minus cos theta whole square plus 6 sin theta plus cos theta whole square. Sorry, the first one was sin theta minus cos theta whole 4. The second one is 6 sin theta plus cos theta whole square plus 4 sin power 6 theta plus cos power 6 theta. Okay. and then it goes on. We have to prove that this is equal to 13. So what we will do in this case is, we will open them up separately and let's see what happens. Okay. So let's start with this. Sin theta minus cos theta whole square. So this will become sin square theta plus cos square theta minus 2 sin theta cos theta whole square. This is a minus b whole square. This will become 1. So it will become 1 minus 2 sin theta cos theta whole square. So this will become 1 plus 4 sin square theta cos square theta minus 4 sin theta cos theta. This is the first part without the 3. This is only this much. Then we will remaining parts we will do. So now let's apply with the left hand side. Left hand side is 3. Let me close the window, there is some noise coming. Sorry for the interruption. Now let's get back to it. What we will do, we will first do it. We will first, instead of sin theta and minus cos theta whole 4, we can write 1 plus 4 sin square theta cos square theta minus sin theta cos theta. Instead of this, we will write 6 sin square theta plus cos square theta plus 2 sin theta cos theta plus 4 sin 6 theta plus cos 6 theta. Instead of sin 6 theta and cos 6 theta, we will do 4 sin square theta whole cube plus cos square theta whole cube, and we will apply a cube plus b cube over here. Okay. So this will become 3 1 plus 4 sin square theta cos square theta minus sin theta cos theta plus 6 1 plus 2 sin theta cos theta plus 4 sin power 4 theta plus cos power 4 theta minus sin square theta cos square theta. Okay. Now what will I do? I will do 3 1 plus 4 sin square theta cos square theta minus sin theta into cos theta plus 6 1 plus 2 sin theta cos theta plus 6 plus 4. Now here I will write down, instead of sin 4 theta cos 4 theta, I can write sin square theta. I will use this identity, a square plus b square is equal to a plus b whole square minus 2ab. So sin square theta plus cos square theta whole square minus 2 sin square theta cos square theta minus sin square theta cos square theta. So what will I get? I will get 3 1 plus 4 sin square theta cos square theta minus sin theta cos theta plus 6 1 plus 2 sin theta cos theta plus 4 1 minus 3 sin square theta cos square theta. Okay, now what we will do, we will multiply everything by, 3 plus 12 sin square theta cos square theta. I think there is a 4 over here. Yes, there is a 4 over here. We have forgotten to write it down. This will become minus 12 sin theta cos theta plus 6 plus 12 sin theta cos theta plus 4 minus 12 sin square theta cos square theta. Now we can see that 12 sin square theta cos square theta minus 12 sin square cos square theta minus 12 sin theta cos theta and 12 sin theta cos theta. This all will cancel out and we will be left with 6 plus 4 plus 3. 6 plus 3 plus 4 and this will be equal to 13. This one also was a little trickier. A little tricky question this was. Okay. So I hope you understood it. Now let's move on to the next question. The next question is, in the next question we have to 1 upon this sin A plus sec A whole square plus cos A plus cosec A whole square is equal to 1 plus sec A cosec A. So what will we try and do? We will try and convert everything into, we won't try and convert everything into sine and cos this time, or let's first open these two identities. Then we will see what will happen. Let's start with the left hand side. And this is sin theta plus sec theta whole square plus cos theta plus cosec theta whole square. Now this will become what? This will become a plus b whole square is equal to a square plus b square plus 2a. We will be using this identity, this algebraic identity. So this will become sin square theta plus sec square theta plus 2 sin theta sec theta, sin theta sec theta. This one will become cos square theta plus cosec square theta plus 2 cos theta cosec theta. Okay, then what we will do, we will sin square theta plus cos square theta will become 1. Instead of sec square theta we will write down, 1 plus tan square theta. Instead of cosec square theta we will write down 1 plus cot square theta. Now we can write down this as 2 sin theta upon cos theta. Sec theta is 1 upon cos theta, and we can write down 2 cos theta. This is cosec. I need to write it down more clearly. It is sin theta. I will write it clearly. It is cosec theta. So what will happen next? We will 1 plus 1 2 and it will become 3. Or what can we do? 1 plus cot square theta, 2 tan square theta plus cot square theta. Okay, let us do one trick over here. We will 1 I'm a little bit stuck over here. Let's see. Tan square theta plus cot square theta plus 2 I am writing 1 plus 1 2 over here, and this is going to be 2 tan theta plus 2 cot theta. Okay, so this will become 1 plus tan square theta plus cot square theta plus 2 tan theta cot theta. Now you need to understand that tan theta plus cot theta is 1. It is just 1. Okay, tan theta and cot theta is 1. So I am multiplying 2 by 1. This is basically by nothing. And 2 tan theta plus cot theta. Now this is a neat trick over here. Now this is a square plus b square plus 2ab. This is a square plus b square plus 2ab. So this will become a square plus b square plus 2ab will become a plus b whole square. Yeah, a is tan theta, b is cot theta. So this will become tan theta plus cot theta whole square plus 2 tan theta plus cot theta. Now you can see this will again become 1 square plus tan theta plus cot theta whole square plus 2ab. Again we are using the same formula. A square plus b square plus 2ab is equal to a plus b whole square. So this will become 1 plus tan theta plus cot theta whole square. Okay, so this will become 1 plus sin theta upon cos theta plus cos theta upon sin theta. Okay, so here what I can use, I will be taking the LCM. This is whole in under square. Then I will use 1 plus sin square theta plus cos square theta upon sin theta cos theta whole square is equal to 1 plus sin theta cos theta. It will become actually 1 plus 1 upon, I jumped one step forward, but I will show it to you this step also. So this will become sin theta plus cos theta, sin theta cos theta. This will become 1 plus sin theta cos theta. So it will become sin theta plus cos theta. Okay, we don't have to do it like that. We can simply write 1 plus sin we can write as cosec theta, and sec we can write as cos, 1 upon cos we can write as 6 theta. I am also a little bit exhausted. This is the right hand side. We have to prove this only, I think. 1 upon sec theta plus cosec theta, 1 upon cosec theta plus sec theta. Yes. Okay. So this was a little difficult question, especially because here you have to write 2 as 2 tan theta into cot theta. If you don't know this trick, it will become very difficult to think in exam at the point, but this is a neat little trick that you should know. Okay, so that you can get the a square plus b square plus 2ab formula over here. Okay, now let's move on to the next question. The next is the 19th question. In this question, he has given us sine cube theta and cos cube theta. Okay, now here what we will do is we will simply use identities. We will use left hand side is sec cube theta upon sec square theta minus 1 plus cosec cube theta upon cosec square theta minus 1. What do we have? We have sec square theta minus 1 is equal to tan square theta, or cosec square theta minus 1 is equal to cot square theta. So what can we write? We can write sec cube theta upon tan square theta plus cosec cube theta upon cot square theta. Okay, now what can we write? Instead of 1 sec we can write 1 upon cos cube theta, and sin tan theta is sin square theta upon cos square theta, not sine. And this we can write as 1 upon sin cube theta. Cot we can write as cos square theta upon sin square theta. So if we cancel out this, we'll cancel out by this, and this will cancel out by this. So we'll be left with 1 upon cos theta sin square theta plus 1 upon sin theta cos square theta. We'll take 1 upon sin theta plus cos theta as LCM. It will become 1 upon sin theta plus 1 upon cos theta. Let's have a look. What did we have to prove? Okay, so this will, yes, so we have proved it actually. 1 upon sin theta we can write as cosec theta, and 1 upon cos theta we can write as sec theta. 1 upon sin we can write as cosec theta, and 1 upon cos we can write as sec theta. Students, if you are struggling with these identities, this is the right hand side. If you are struggling with these identities, you need to learn them, and I have given a link in the description where you can go and learn them. Okay, where you can go and all the identities are written over there. Here we can see it is, the left hand side is sin 6a plus cos 6a plus 3 sin square a plus 3 sin square a cos square. Let me have some water. Okay. Now here we will be using again a cube plus b cube. Which what identity we will use? A cube plus b cube. So we will write left hand side as sin square a whole cube cos square a whole cube plus 3 sin square a cos square a. So a cube plus b cube is equal to, we had told you a cube, we have already used this quite a few times today. A cube plus b cube is equal to a plus b, a square minus ab plus b square. So a over here is sin square a, b is cos square a. So we'll write it as sin square a plus cos square a upon sin 4a minus 2, sorry 2 is not over here, minus sin square a cos square a plus cos 4a cos 4a. Yes, I have written theta over here. Sin square a cos square a. Okay, and in the end plus 3 sin square a cos square a. So this will become sin square a plus cos square a will become 1, and over here sin 4a and cos 4a we will apply the formula a plus b, a square plus b square is equal to a plus b whole square minus 2ab. Okay, so this will become 1, this will become sin square a plus cos square a whole square minus 2 sin square a cos square a. Okay, minus sin square a cos square a plus 3 sin square a cos square a. So it will become 1 minus 3 sin square a cos square a plus 3 sin square a cos square a. This and this will cancel out. We will be left with 1. This is the right hand side. Okay, so we have done this one also. The next one is, in the next one we have to prove sin A upon sin A plus cos A upon sin A minus cos A plus sin A minus cos A upon sin A plus cos A. Okay. So what will you do over here? We will take the LCM of the left hand side. We'll take the LCM. We will do what? We will start with the left hand side. We will make it like this: sin A plus cos A upon sin A minus cos A plus sin A minus cos A upon sin A plus cos A. Now what we will do? We will take the LCM of the denominators, and it will become sin A minus cos A, sin A plus cos A, and this will become, the numerator will multiply with sin A plus cos A, so it will become sin A plus cos A whole square, and this one will become plus sin A minus cos A whole square. So this will become sin square A plus cos square A plus 2 sin A cos A plus sin square A plus cos square A minus 2 sin A cos A. And denominator will become sin square A minus cos square A. A plus B, A minus B, sin square A minus cos square A. This will become 1. This and this will cancel out. This will become 1 plus 1. And we have to convert the numerator into cos square A. So we'll, instead of sin square A, we'll write down 1 minus cos square A minus cos square A minus cos square A. 2 upon 1 minus 2 cos square A. This is the right hand side. This is the right hand side. We have proved it. Okay, this one was simpler compared to the previous ones. Now let's move on to the next question. Here, what do we have to do? Here we have to prove that cos A minus sin A plus 1 upon cos A plus sin A minus 1 is equal to cosec A plus cot A. Cosec A plus cot A. Okay. So what will we do? We will first convert everything into, this time we will convert everything into cosec A and cot A. How will we do that? We will write left hand side, and we will divide the left hand side by cos A. We will divide the left hand side by sin A actually. Yes, we will divide the left hand side by sin A, both the numerator and the denominator. So it will become cos A plus sin A plus 1 upon cos A. Okay, this is minus cos A minus sin A. Cos A plus sin A minus 1. So this will become, we will divide it by sin A. It will become cos A upon sin A minus sin A upon sin A plus 1 upon sin A. Cos A upon sin A plus sin A upon sin A minus 1 upon sin A. So what will this become? This will become cot A minus 1 plus cosec A. And this will become upon cot A plus 1 minus cosec A. Okay. Now what we will do? We will, instead of 1, we will write cot A plus cosec A minus 1 upon cot A plus 1 minus cosec A. So instead of 1 I will write down cosec square A minus cot square A. So it will write cot A plus cosec A minus cosec square A minus cot square A. Cosec A plus 1 minus cosec A. Then what I will do? I will write cot A plus cosec A minus cosec A minus cot A, cosec A plus cot A upon cot A plus 1 minus cosec A. What will we take common? We will take common cot A plus cosec A. We will be left with 1 minus cosec A plus cot A. This is exactly what we have in the denominator. We have same thing 1 minus cosec A plus cot A in the denominator. These both will cancel out and we will be left with cot A plus cosec A. You can see this is the right hand side, cot A plus cosec A. Yes, cosec A plus cot A. We have to prove this only. The trick in this question is that instead of 1, we have to write here cosec square A minus cot square A. Okay? I hope you understood this question also. Now, let's move on to the next question. The next question is the 23rd question. In the 23rd question, what we will do is start with the left hand side. It is tan A upon 1 plus sec A minus tan A upon 1 minus sec A. We will take tan A common. We will get 1 upon 1 plus sec A minus 1 upon 1 minus sec A. We will take this tan A 1 minus sec A minus 1 minus sec A. Okay. What will happen is 1 minus sec square A in the denominator. A plus B, A minus B, 1 minus sec square A. Now what will we do next is we can write tan A plus minus will cancel out, minus 2 sec A upon 1 minus sec square A. Tan A minus 2 sec A. 1 minus sec square A is tan square A. 1 minus sec square A is tan square A. Now I will write this tan square and tan will cancel. So I will write minus 2. No. I have done a mistake. 1 minus sec square A, this will become, okay, I will write this step. Sec square A minus 1 is tan square A, na? So I can write 2 sec A upon sec square A minus 1. So this will become tan A 2 sec A tan square A. Tan will cancel out. It will become 2 upon cos A and tan square A will become sin square A. Okay. This will cancel over here and the tan will become sin A upon cos A. Sin and cos will cancel out and this will become 2 upon sin A is equal to 2 cosec A. This will be the right hand side. Okay. Now let's move on to the next question. This is the 24th question. In the 24th question, what we will do is we will start with the right hand side, because the denominator is much simpler in the right hand side. So we will start with the right hand side and then we will move forward. Okay, what we will do, we will start with the right hand side. 1 minus cos theta plus sin theta upon 1 plus sin theta. Now what we will do, we will write it like this: 1 plus sin theta minus cos theta. We've written it like this because the denominator also has 1 plus sin theta. Okay, then what we will do, we will multiply both the sides by the 1 plus sin theta minus cos theta upon 1 plus sin theta. This will multiply by 1 plus sin theta plus cos theta upon 1 plus sin theta plus cos theta. Okay, so now what will become is, we will get a square minus b square. This is a minus b and this is a plus b. So what we will get, 1 plus sin theta whole square, 1 plus sin theta whole square, and this will be minus cos square theta, and this one will become 1 plus sin theta and 1 plus sin theta plus cos theta. See, this term is exactly what we want to here. We have to adjust the rest of the terms. So for the numerator, what we will write? For the numerator, we will write 1 plus sin square theta, and over here we will write down, sorry, it is not 1 plus sin square, it is 1 plus sin theta whole square, and here we will write minus sin square theta, cos square theta, we can write 1 minus sin square theta, and here we will get 1 plus sin theta, 1 plus sin theta plus cos theta. Now we will take 1 plus sin theta common, 1 plus sin theta whole square minus, this is a square minus b square. You will get 1 minus sin theta, 1 plus sin theta. With 1 you can do that. That is a good property of 1, that the square of 1 is also 1. 1 sin theta, 1 plus sin theta cos theta. What will we do next? We will take 1 plus sin theta is common. We will be left with 1 minus 1 plus sin theta upon 1 plus sin theta upon 1 plus sin theta plus, here we have plus cos theta. So what will happen is, actually I did it wrong over here a little bit. We won't be left with 1, you will be left with 1 plus sin theta. Minus 1 plus 1 will cancel out. This one will also cancel out. So it will become 2 sin theta upon 1 plus sin theta plus cos theta. This is the right hand side. Okay. Now the last question. The last question is 1 plus cot square theta, 1 plus cosec theta is equal to cosec theta. Okay. Now this was more tiring than I expected. Now we have come to the last question. So we will be using the identity again. 1 plus cot square theta is 1 plus cot square theta is cosec square theta. 1 plus cot square theta is cosec theta is equal to, we have to prove this. Okay, so the last one is 1 plus cot square theta. So we will simply write it down as 1 plus cot square theta upon 1 plus cosec theta. Now cot square theta I can write down as cot square theta, I can write as cosec square theta minus 1. Okay, so I will write 1 plus cosec square theta minus 1 upon 1 plus cosec theta. Now here I will use a square minus b square. This is 1 square. 1 is okay. So a plus b, a minus b. So I can write 1 plus cosec theta minus 1 and 1 plus cosec theta upon 1 plus cosec theta. This and this will cancel out. So I will be left with 1 plus cosec theta minus 1. This and this will cancel out. This will become cosec theta. This will be the right hand side. Hence proved. Okay, this will be the right hand side. Hence proved. Students, I hope you practiced along. I hope you are still there and you practiced along. All the formulas for both algebraic identities as well as trigonometric identities I will link in the description, and I hope to see you in the next video. Thank you and have a good day.